Hi mathletes, today we're going to talk about rounding. We're going to start with whole numbers and then we'll end with decimals. What is rounding? When we round a number, we are replacing it with another number that is approximately equal but has a simpler representation. The new number is less accurate, but it's easier to use. For example, here we have 458,654. Rounded to the nearest thousand, this number becomes 459,000. Although these two numbers are not exactly equal, they are similar to each other and it's approximate. 459,000 is a lot easier to use when you're trying to do computations. Here's how to get started with rounding. The first step is to underline the digit in the place you are rounding to. The second step is to look at its neighbor to decide if the underlined digit should stay the same or go up by one. We're going to look at an example next that's going to help make these instructions seem more clear. We're going to start with the number 265,478, and we're going to be rounding it to the nearest thousands place. It's really important to know your place values. If you don't know your place values, it's going to be very difficult to round to the correct place. So step 1. Looking back, that step was said to underline the digit that is in the place you are rounding to. 5 is in the thousands place, so that gets underlined. Do you remember step 2? Step 2 said to look at the underlined digit's neighbor to the right. Its value will tell you what to do next. A common mistake is to look to the left. Remember that right is right and left is wrong in this case. Its neighbor is 4, so now what? You can think of rounding like a car driving up the hill. If the car can't make it to the top of the hill, it's going to roll back down. The underlined digit will stay the same in this case. If the car does make it to the top, or it goes over, it's moving on. So the underlined digit will go up by 1. Your two choices for an answer are to keep the underlined digit the same or to move the underlined digit up by 1 value. Looking back at our example, we have a neighboring value of 4. The car is going to get stuck and roll back down the hill. That means the underlined digit is going to stay the same. If the 4 had been a 5 or greater, we would have had to change this underlined digit to 1 up, which is a 6. We still have a couple steps left to finish our problem. We know that the 5 isn't going to change. We do, however, need to change all of the numbers after the underlined digit to 0. So the 4, 7, and 8 become zeros. Everything to the left of the underlined digit stays the same, so the 2 and the 6 can stay in place. Let's try another one. We're going to round the following number to the nearest 100. I've started you off by underlining the correct place. The 2 is the value that we're going to be looking at. Now step 2. Try that on your own. Step 2 involves looking at 6, which is the neighboring digit to the right of the 2. 6 is over the hill, so the car is able to move on. This means that we need to increase our underlined digit by 1. Our 2 now becomes a 3. To finish up, we need to take all the digits to the right of the place that we rounded to and change them to 0. So our final answer would be 190, because remember the numbers to the left of our value stay the same. 3 is our new number, and now we have 0, 0. 190,300 is our rounded value. We're going to try some more. Here's another example. When we round 572,899 to the nearest 10,000, we're going to underline the 7, we're going to look at the neighboring digit, the 2. The 2 does not get the car over the hill, so the 7 is going to stay the same. Everything after the 7 is going to go and become a 0. So our final answer would be 570,000. Much simpler. Here's one more that I'm going to talk you through. 456,012. We want to round it to the nearest 10,000. That's this 5. We're going to underline the 5 and look at the digit to the right, which is a 6. The 6 means that the car has gotten over the hill. So this 5 is going to increase by 1 and become a 6. Our rounded answer is now 460,000. I have a couple for you to try on your own. Here's some decimals. I'd like you to round this decimal to the nearest tenth. Then round this decimal to the nearest tenth. For these two decimals, please round them to the nearest whole number. Please pause the video and give this a try. Use the exact same steps that we did when we rounded whole numbers. Hopefully you've already given these a shot, but I'm going to start working on these. So if we're rounding this number to the nearest tenth, that means I'm underlining the 2. I'm going to look at its neighboring value, the 1, to decide if my value is going to change or stay the same. 1 means that the car has not gotten over the hill. So my answer is going to be 0 and 2. Whoops. I'm going to erase that because that 2 got a little messy. 0 and 2/10. Everything after the original number has to be a 0, and remember, adding zeros at the end of a decimal doesn't change it. So my final answer here is just 0 and 2/10. Here I'm going to do the same thing. I underline the 9 and I look at the 8. 8 means that the car has gotten over the hill. So this 9 needs to be changed to a 10. What happens when you need to add a 2-digit number to a 1-digit slot? Well, I can't have 0 and 10/10. That doesn't make any sense. I can't have a 10 in a 1-digit slot. So instead, I'm going to keep the 0 here. I'm going to put that in blue. I'm going to keep this 0 the same, and I'm going to carry the 1 to the next spot. It's just like when you do addition and you need to carry it over. So my final answer is going to be 1 and 0/10, which is just the same as the number 1. When I round it to the nearest whole number, I'm going to do the exact same method. The whole number means to use the ones place. So here I'm rounding to, oops, sorry about that. Here I'm rounding to the nearest ones place, and I'm going to be looking at the 9. 9 means that the car has gotten over the hill. So my 3 is going to increase by 1 and go up to 4. The nearest whole number means that there will be no decimals. All of these numbers have been changed to 0, so my answer is just 54. Here again, I have a 9, and I'm going to be using this 9 to determine if my first 9 should change. A 9 means that the car has gotten over the hill, so this 9 needs to change. We have the same problem here. We have a 6 that's going to stay the same. We have a 7 that we're going to keep. And now we have to fit a 2-digit number in a 1-digit spot. We're going to do the same thing that we did in this problem. We're going to keep the 0 where it is. So the 0 is going to be in the spot all by itself. And then this 1 is going to carry over to the 7. It's going to go up a place. So my final answer is going to be 680. I have a few more examples for you, and these you can save and bring them into class tomorrow. Round these numbers to the nearest hundredths. Pause the video while you write them down, and then try them on your own.